good.
Okay, so we are doing instructional worksheet 9, lesson 3. I'm looking for my stuff here, okay. So we're gonna be talking about thermodynamics, and that's the study of how heat moves. And everybody should be aware of how this works. I need all computers shut, no computers open.
Oh.
No computers open, shut your computer. Okay, so one thing that you already know, which way does heat move?
Right.
It moves from hot to cold. Another way to say this is it moves from low energy, or excuse me, high energy to low energy. Heat does not rise, but hot air rises. So here we have a heat transfer, and a heat transfer will always be from higher to lower, always from higher to lower. Does that make sense to everyone? We have two things we're going to talk about here that you're all familiar with, and these are insulators. See if I can make this lighter. I'll make it. I have a feeling this isn't going to work very well because this isn't my iPad. Insulators and conductors. An insulator, everybody's familiar with. Does anybody here know what a down coat is? A down coat has goose down in it, and they're great insulators. That's why, like, ducks and geese don't die in the wintertime. They've got, like, really fluffy feathers that keep them warm. Very fluffy feathers that keep them warm. Materials with air pockets are good insulators. So, you know what styrofoam is?
Yeah.
So if you take styrofoam and squash it down, you can take a styrofoam cup and make it teeny tiny. Did you know that? Because what is styrofoam mostly?
Air.
It's mostly air. Have you ever looked at your windows and seen that there's a space, a gap in your windows? That is an air. Sometimes they're triple pane and you'll have like glass, an inert layer of gas, another glass, an inert layer of gas, and then your third pane.
Like your car windows?
No, like these, I don't have good ones here, but have you looked at your windows at your house? How many people have double or triple pane windows? And then sometimes if the seal breaks, have you seen sometimes you get moisture in those? You know, they start looking cloudy and that means you have a broken seal. So insulators slow down heat transfer. Wood is a good one, styrofoam is a good one. Conductors allow easy heat transfer. Most of the time, your good conductors of heat are also good conductors of electricity. So metals are good conductors. So thermal energy is conducted in 3 ways, and that's conduction, convection, and radiation. Conduction is characterized because it transfers heat through touching. Objects have to be in contact. So you have to have atoms in contact with other atoms in order to have conduction. How would we define kinetic energy? As energy of what? Movement, energy of motion. All atoms have electrons that are moving, right? They're all like spinning around like crazy. That means they have kinetic energy. The more heat energy you put into them, the faster they're moving. Does that make sense? So the hotter something is, the faster the electrons, the atoms themselves are moving. When hot atoms bump into cold atoms, they transfer that energy. So they actually transfer energy. Conduction transfers heat by atoms colliding and transferring energy. Closer atoms, more conductions. So that means solids tend to transfer heat better than liquids. I'm sorry that's not easy to read, but you've got your sheet in front of you. So solids transfer heat better than liquids. The best conductions are solids. Gases are bad at conduction. So it goes from solids are good, then to liquids, then to gas. Good conductors, good insulators. And liquids are sort of in the middle. They can be good conductors, they can be bad conductors. If you set something on a desk or a table and then leave for a while, if I take like if I take a brick out of a freezer and I set it on the table, how will the cold flow from the brick to the table, or will the heat flow from the table to the brick?
Heat will flow from both.
No. Where will the heat flow? Hi, come on in. So how will heat flow? From the table, from the cold to the hot, or from the hot to the cold? Hot to the cold is correct. Now also there is gonna be air, but if we come back the next day, these two substances will be at something we call thermal equilibrium, same temperature. That's a big fancy term for writing same temperature.
Same temperature as before?
Same temperature as one another. So if you left that Alexis's bottle of water sitting there, is it cold or room temperature right now?
Cold.
So if you leave that sitting there until tomorrow, it'll be the same temperature as the room. Do you agree?
Mm-hmm.
Yep. And that would be called what? What two words?
Equilibrium.
Thermal equilibrium, because they're the same temperature. So conduction is the easiest one, or most easily understood. Convection is when we transfer heat through currents in gases or liquids. So no currents, no convection, no convection. So which state of matter cannot have convection? Solids can't have convection. Do you know that oceans have currents? Do you know that there are air currents? Yeah, I think you do, because we live in Kansas and we experience them in the form of wind. Do you agree? If the wind is because of an air current. And there's currents in oceans, so there are currents. Hot liquids and gases are dense and rise, and they cause convection currents. Hot liquids rise. So if you have like an ocean current, a hot liquid, a hot warm water that's getting warm over by the equator, and it starts flowing and it's flowing down underneath. What happens when it hits cold water? The warm water rises, pushing the cold air, and you get it does make big ocean currents. So these currents are applicable to both solids and liquids. Gases transfer heat poorly through conduction, but convection currents can be pretty fast because you can get pretty big winds moving stuff around. Solids can't have them, and much of our weather on Earth comes from convection currents. The sun warms the air, and warm air rises, wind is called. When the air cools, it falls back to the ground. So, you've got wind like boom, boom, boom. And if you look at like weather maps of how weather is supposed to occur, they literally go like this, in different bands on different latitudes. So, and then our winds can also shift because of fronts. So that's convection. And the third type of energy transfer I want to talk about is radiation. And were it not for radiation, we would not have life here on Earth. Radiation transfers heat through electromagnetic radiation. It occurs in a vacuum, and a vacuum is defined as empty space. Radiation transfers heat through electromagnetic waves, and we're not going to learn the whole electromagnetic spectrum, but if you look back in the room, over in that corner by that door, I've got all the electromagnetic spectrum up there. And there's a song that you learn if you take chemistry: radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays, and those are our electromagnetic types of radiation. Radiation from the sun, if you think about the sun, transfers heat through electromagnetic waves. They're really interesting because they go in all directions. I want you to visualize the sun. We're getting hit by energy from the sun right now, correct? No matter where you are in our solar system, no matter whether you're 90 degrees above us or below us, you are getting electromagnetic radiation from the sun. Do you concur with that? You're getting electromagnetic radiation from the sun. It goes in all directions. Radiation doesn't require any contact. Electromagnetic radiation can travel through a vacuum, through deep space. We can see light coming through deep space in the form of stars that come to us, and we can still see a point of light. And that's traveled to us through a vacuum. Does that make sense? It's really sort of wondrous what you can see. Radiation can go through transparent materials like glass. Radiation can go through barriers like glass. Now, you can also have conduction through glass because air particles hit the glass, right? Or you could set something and have, I guess you could have an air current hit the glass too, but all energy on Earth comes from the sun. So every bit of energy that we have comes from the sun, one way or the other. Space is a vacuum. Deep space is a vacuum. In the world of science, we describe a vacuum as the absence of any matter. It's empty, not a molecule, not an atom. Did you know this? Did you know that dark objects absorb more radiation than light objects? Did you already know this? I think you did. Did you know that shiny objects reflect better than dull objects? I think you know that. That's what we call intuitive, things you already know. So there's two pictures down here. High absorption of radiation heats fast, and low absorption of radiation heats slowly. Okay? So a lot of information on the front of this one. We're going to continue with this in a moment, but just because I hate uploading giant videos, I want you to stop right now